Welcome everybody. I see the talk today is this research station Svanhovd, NIBIO. NIBIO is the Norwegian Institute of Bioeconomy Research. So, and everybody know what bioeconomy is about. That's something I will tell a little bit later now, but here you see the picture of a place in July. So the alley down to the housings to our station. I don't manage all these things. This is a picture taken in December. This is how the evening is looking in December. You see a light and buildings are our institute. These things here, this one is the old one from 1930s, and this is a part of the old one. This building here is more modern, from 1993. This is how it's looking from the roof. This is a picture showing the entrance of my office, and my office where I'm just now is just behind there. It's the wall. And this is the main entrance, and here you see how it's few impression pictures from the summer and the winter. So you see sled dogs, and here's the church, which is a few 100 meters away from this building. This is a photo from a helicopter, just to know where this place is located. This is the red dot, everybody, I hope. This is the Pacific River, which is the river between Norway, which is here, and this is on this side. The water itself is going directly in the middle of the river, just like this. It's flowing from south towards the north, which is this direction. So my neighbor town, which is the closest neighbor town, is Nickel, which is 10,000, 12,000 people living. Here you see our research institute, our station, and that's just there is my office, right? And actually my home is just down there. Now, so I'm in my kitchen window. I see out towards all this, which is Russia, on the other side of the river, and then a little bit of the Norwegian side. From early autumn, you can see the yellow leaves from the birch trees. In my area, the trees is getting a little bit yellowish, approximately in the middle of September. So see another picture from the old part of the houses, and what this is, not the Norwegian flag, this is the Sami flag, the Sami people's flag, which is their celebration on 5th of February as for the ethnic group. The day of my place started in 1936. I became a research station approximately in 1993. Before it was a demonstration farm, actually. So 1930s until 1993, it was basically research and demonstration farm for agriculture. And they built more and more things into this new part of the research station. And from 2015, we became Svanhovd. I hope bad English. I know that a lot of you is talking much better English than me, so I hope you understand what I try to say.
It's very
good. My institute today is NIBIO, which is then this Norwegian Institute of Bioeconomy research. And here you see Svanhovd, and here other sites, other stations of NIBIO in Norway. Altogether, NIBIO is having more than 750 employees. We at the Svanhovd, we are 21 persons employed by NIBIO. The economy is actually simple. It is the value which is giving, for example, by the blueberry. When we eat the blueberry and use the blueberries, then this is giving a good feeling. It is making food for us. This is ecosystem service, and ecosystem services, a lot of ecosystem services, the bioeconomy. Using of the nature, and but only nature, but also things from nature, which is clean water, drinking the clean water, part of the economy, bioeconomy. Making fishing, getting for food, that is a part of bioeconomy. Lectures about these things later on. So those of you that like to listen to such things more carefully can join us later on. So a small map. This is my primary working area in Svanhovd up there. See, we are quite far east. Actually, that we are about Istanbul. And far east here, from Poland and Romania. And here see the approximately the level is the polar circle. So we're above the polar circle by 500 kilometers approximately. So my focus area, this is 1/3, 25% of Europe approximately. Here's my located. This is Murmansk, which is the biggest city in this Barents area. This area which you see here in this yellow color. 1/4 of Europe, but only keeps about 1% of Europe population of people. How many people is living in Europe? This is a polar circle that it says. You know the Rovaniemi, which is then supposed to be the Santa Claus home city. So I'm Santa Claus. Like some of the picture you saw in the summer, we have a conference center. So here, some of the lucky winners the competition of the EDU-ARCTIC will be come to Svanhovd and will be hosted me for a couple of 10 days or 2 weeks or something. And the flowers and such is looking like such. What do you see? A botanical garden in there of station, where bushes, the flowers, the perennials of 400, nearly 500 types of. Here you see the lilac. So this registration of the Arctic, this is one of my plants which I'm going to make the registration from. Actually quite a lot of vegetables, even though it's very, very far north. And this is all types of vegetables has been produced through some 100 years in the north. And they were through this a strong, interesting climate. But all small things, but we need to make some small adjustments for the climate and for the insects, the pest insects, really. But the growing of vegetables is more easy in the north because so many pest insects or illnesses which is influencing on the productions. So in the garden we have a lot of, not a lot of, but we have young people participating both through the schools, but also during some parts of the summer we have people which is working, actually, young people which is working in the garden to utilize, to make the vegetables and how to use the nature wisely. So part of my neighbor area, this is the of the Barents Sea. So the Barents Sea is going into Kirkenes, just north of me, so about 40-45 kilometers to the north of me, then Barents Sea is open. What you see here, you don't see much trees at all. So on the coastline, there is even alpine mountain areas, which is going all the way down to meeting the Barents Sea. This is in Europe where you can meet the alpine area just like this. That's interesting. This is a picture from end of July. See on the hills behind the red dot now, there's even snow. Accumulated some places like this in glaciers. So we have glaciers of different age, different parts of the region. This is a picture close to Tromsø, which is about 800 kilometers to the west of me. Much more closer area, and just a few tens of kilometers, 10 kilometers approximately. This is here you see a birch forest, small alpine mountainous birch forest. You can see the tree line, the line between the alpine and the mountain forests. You see the different colors of the different stones, the different geology, and that is something that we will tell about later on another lecture. You see a huge variety of different type of minerals, stones, and landscape. This just around me, more or less. Here you see small hills, and on top of the hills there is mountain alpine areas, but this pine forest. So this is a part of the big taiga. Is stretching like this, the green line that you see here. So my area is named Svanvik or Svanhovd. Svan is the station, and my village is Svanvik. Nickel, Asvik River that you saw making the border river between Russia and Norway. To the west of me we have Finland, or up here actually. We have Kirkenes, where you saw the boat. The boat was approximately there. You saw in the picture a little bit earlier. This area in there and down there, then we shift from one climatic zone. You have learned that the different climate means different type of precipitation, by how the rain is falling, how much rain and how much snow, what temperature regimes is working, and these things that makes the different type of climate. So the climate zones is very, very narrow, very, very closely to each other. So here is one climate zone ending, and the next zone is ending here, and then you have a new zone here down to Kirkenes. So from the Barents Sea, which is up here, and the fjords and up to my place, then 3 different climatic zones. That's it. Very for scientists, other people when you know about the differences. Very well. Siberian spruce, quite rare in the taiga forest, and then pine trees. The taiga, which is going from my area, actually the northernmost taiga in the European Russia. So this part of Russia here is very interesting for Russian scientists as well. So that's why they have made a zapovednik or nature reserves in the area to make illustration of what's happening in their northernmost part of the taiga. In part of Russia, the taiga is going a few more, about 50 kilometers more north than you find it here in my area. First, the taiga is much more southern, and all in here is this taiga because here you have high mountains, like with no tree at all. This is not non-forest mountains. The mountains. So, birch trees is the most one. Then we have this, and then we have the populus trees, which is another important part of the forest. The changing the composition through the land as it stretches onto the Pacific. Oh, but this is another small picture showing the mosaic between the water systems, the forest and fires. This is a picture from the autumn. Look carefully here on this area, and you see there's a lot of stones. This is actually just like a field of big stones, big boulders, like a chair or a table, irrigated through the freezing processes from glacier period. So this land was melted in about 10,000 years ago from the big glacier period. And, the trees and the people and the animals established in the areas very, very quickly after melting. Here you see a small creek or a small river, and you see the water is running quite high in the rain. Wet land as well. You are the domestic reindeers. There is no wild reindeers in this part of northern Norway. In the Pacific, around our station, there is about 4,500 reindeers in the summer and a little bit more than 3,000 reindeers in the winter. Now 300 moose in our forest around us. This is young moose. The brown bears. So 40 brown bears around in my area here, and then close to us, and then in the Norwegian, Russian, Finnish territories in this community there is about 60 bears. No polar bears in this area. No polar bears on the mainland of Norway at all. A bit with the bears. So the things we are working is to prevent bears to be garbage bears that work or eat a lot of garbage and these things close to people and get attracted to people. In the brown bear garbage bears is getting a bigger and bigger problem. So people in both in Poland and in Romania with these things. And there is very, very sophisticated and very, very strong. And how very well how to open a box of of, and they're happy when they find even a little small piece of a bread or a box with the tomato, mackerel, just the small drops of mackerel oil is a very, very nice present for them. And then when they learn, the problem with the bear is when they learn these things, it's just like a switch in the head, click, and they become the problem bears. And it's very, very difficult to learn them not to become problem bears working and destroying garbage cans and going into villages to get the food from the garbage. Sometimes this bear is getting very, very close to people and is not afraid of people, and then they even chase people, and people very, very, very friend. And then something needs to be done. So here I am working with one bear. In there is also a lot of different birds, like the of berries. Unfortunately, I did not find the word in Romanian for this berries. But as you see, all the ground behind there is of the berries, the cloudberries. So the production in the high north can be extremely high. Also, like blueberries and other berries, the production can be very much more higher compared to other areas. So here's sorry, one of my colleagues came with an insect. This one, you see it? So
I think we've lost you out again. Oh, can you show again?
yeah, this is one of my colleagues came with an insect. Just so nice. So I look for what this is. Actually, this is a moth type of. I will have to look that later on. Okay, such is the days. Originally, the Stone Age people that lived in the area disappeared about 3,000 years ago. 1,000 years ago. And the Sami, this eastern group of Sami people, this is Scout Sami people, is the oldest group of the oldest groups of the Sami people. They lived here about 2,500 years ago. So it's using the forest, but also the rivers and also the sea for the different type of food production and gathering of different food. They also have a few reindeers, but not like a reindeer herding in big herds. That is quite much more modern thing of pasture and reindeer herding. Sure, that we will tell later on. But actually, you know, the reindeers was milked. So the importance of keeping the reindeers in a rope and then getting the milk from them, that was a historical part, very important. Eating the meat from the animals and such, but also getting the skin, the boots. So the boots on this man is actually made from the reindeer skin. Forests are very interesting, and the forest in the north and the forests in the tropic and everywhere is actually very, very different. So the forest you have in Poland have two different functions compared to the forests in the high north. One thing that forests is doing in all our area is making the stability of the climate. So when you're cutting down the trees, then you're destroying the microclimate, the local, very local climate. So you see here, this mist, this important part which is produced by the forest, which is protecting the, making the more stabilities of the climate. So very important part. When you cut down the forest, then you destroy this production of the mist, and then you have another type of climate which influence on the ground of the forest and the soil types. The forest is very, very important. Basically, in 80s and until the 1970s, planted a lot of pine trees in the areas and flooded them on the different rivers. This is on the Pacific River again. And there was a huge extraction of timber. Cutted material, cutted banks. This is not houses. This is just stubbles, stockings of cutted material, plank material that produce more than 1 billion cubic meter. 1 million cubic meter of production per year. This meant quite a lot of problems actually because of doing this, because they destroyed the rivers. They made bulldozers and tractors into the rivers to clean the river, so the water was flowing more straight, and the timber was easier to float on the rivers. Destroyed quite a lot of the ecosystems and also the fish populations, like the salmon and trout. Pollution is another thing that we have worked in this area, and what we get into the Arctic is having a big problem to get out of the Arctic. But it's not only staying in the Arctic, it also keeps influencing on us what's happening in the Arctic. That's one of the things that we want to tell our EDU-ARCTIC project. My very close neighbor, this is from Nickel. Actually, you can see between the lights in behind red dot, that's the place where I'm staying now. So this is about 10 kilometers away from me, this enormous nickel melter. It's the 6 most important nickel melters in world. Factory. The effect of the nickel, which is there, and my place there, is then in the smoke that you saw on the picture, the chimney, and also the smoke coming from the fabric plant itself, making a contribution with a lot of sulfur dioxide. Actually, now this nickel melter is among the world champion. Probably the champion of the world emission of sulfur dioxide. So influenced by the sulfur dioxide, which is making the environment more acidic. They emit a lot of nickel, so the nickel is also going out because they melt the stone to make the nickel concentrate. And then when they're burning the stones and melting the stones, then you have to damp with the metals, especially nickel, but also copper and a lot of other different metals. And this is flowing in the air, going towards the Barents Sea. And then you have this stretch, this type of this stretch here among these pollutants. With us. Like this bird, this flycatcher, pied flycatcher. I know the name in Romanian. But this name of it. This is an indicator of Europe to test how bad the influence of the pollution is like. So we do a lot of different tests by making the nest boxes. A bit like here you see 1, 2, 3, 4. and 5 is different places where we are making these nest boxes. And we have a set of nest boxes. Each of these places we have 40 nest boxes, bird, and then can make investigations on how many chicks are produced and how big they are, how heavy they are, and follow them up and see how many of them is surviving to fly out, and also putting the rings on the leg of the. Then we can catch the bird later on, how they have been developed the next year, for example, and the years after. Something I would like to tell more about later on another special lecture about pollutants. So make work with small mammals, the grid wall. I don't dare to try to say these words. It's complicated, at least for me. I'm sorry. My Polish is not so good. But nickel melter from an aerial photo. So this black thing is part of the nickel factory, and this the slug, the remnants from the melted stones. Here's a lake, and here is the Pacific River with the border between Norway and Russia. Here is my place, and here is a place where I worked with these small mammals. I will show you some small figures from these walls. Here we started with our investigation in 1986. Sorry, 1986. You see, the population was just making small, strange jumps. And when we went to 2006, something happened, and they started to jump big populations. So this number of mice with one day with halves. So that in 2015, the average was 72 mice per day in 100 traps. Okay. So this is something normal in non-polluted areas. But here is actually some where this is not normal type of mice variation of the population, normal variations, and this is actually because of the pollutant. So the pollutant from the nickel melter was much higher in the 1960s, 1970s, 1980s, and 1991 when the perestroika came. Then there's a change in the economy, and in 1995 there started a change in the economy of the nickel melter. So a change of the nickel melter economy made change in the pollution that came out from the nickel melter. So the pollution is much less now compared to earlier in the 1980s and 1990s. The pollution was something like 4 times higher. Okay. The pollution in the mice then. This is just to show the different level of the different pollutants. Here you see the different heavy metals. This is a lot of different heavy metals like you see here. And the different species. So you see there is variance indices, and you see variation between the heavy metals. These are small just show the liver of the mice, so the concentration of the metals in the liver compared to the heavy metals in the kidney of the animal. So this is showing that the kidneys have higher concentration of heavy metals compared to the liver. This. Why? This will speak in a later lecture about how and why these things is happening. Let's just show you. So there's another small, very interesting thing here from these walls that is having lower concentrations of heavy metals compared to the young animals. So juvenile means youngsters, agers, for example, but not babies. And the adult is then the grown-up mice. So the mice is having lower concentration compared to the young ones. That's very, isn't it? This picture as well, because this is showing the creation in 2010 compared to 2015. So we see the pollution have declined through the years or in this different areas. Such things a little bit as well. Just showing also the concentration of the heavy metals in the kidney, which in nyre is there, and it's there. This is a liver, this is a kidney in the young ones. So the kidneys is having higher, and so in the adult, the kidney is having higher concentration compared to the liver of the adult. This means that there is not a mechanism which is changing between these organs, so in the same role of and functioning, basically, a young one compared to the adult one. Okay? Then, actually. Also with a lot of different cooperation projects with other institutions. Here's this EEA grants from Czechia. We're working with the isotope fingerprint of heavy metals in different type of environment. So in these lichens, the gray birch lichens, and then the dark black birch lichens, then we check out contamination of heavy metals. Then the different heavy metals is then analyzed for their isotopes. I have a small description about isotopes in Poland and Romania. But basically, then the different type of isotopes have different sources. So, for example, the nickel isotopes coming basically only from universe, one type of isotope, and then there's 6 types of isotopes which is made humans by the different type of melting stones and making different metallurgic processes. Then you're changing the isotope structure of the metals. And different fingerprints, depending different type of isotopes when you make the different type of productions. Yes. And then when you combine with the copper and the nickel other metals, then you get the different type of sources for the pollution. This is something that I will make another more detailed about later. But one thing like lead. So Lambo, the lead is getting more and more into our environment. It's increasing quite quickly. We also made an investigation of this. So from the part of this coming from car production, or not car combustion, meaning the driving of cars. So by the diesel and the benzene, the gas, different type of isotopes depending on what oil field the petrol, the diesel, and the gasoline is coming from. And then all different type of substances which is put into the gasoline and the diesel, then see where this has been produced. See, actually, if the lead in the environment in my area around us here is coming from Russian petrol or Finnish petrol or Norwegian petrol, being the detectives and looking for who is making the pollutions. With a lot of other projects of investigation, so ecosystem services, like these things I told about the blueberries. But in our town, you have green trees, and the effect of trees in our town is something just similar to what I told about the effect of a tree in the forest. So one of the big things that making the wind, it's making shadow, so temperature is not so very high, and it's collecting dust. So pollution dust from cars and roads and all such, this is caught up by the trees. These ecosystem services of cleaning the air in the town is important by the green areas and the trees that you have in the towns. So yeah, I think you understand Bulgarian very well. It was a project that we was mapping the ecosystem services in all the towns in Bulgaria. So I work with approximately more than 50 projects last year. So I had 53, 56 different projects, depends. This year I only have 30 projects so far. The other project we are working is birding or ornithological tourism. So looking for birds is getting a very important touristic in a way, actually. So to make the birds is then an ecosystem service that makes money into the local communities and rich companies also. But of course, how to make this sustainable, how to make this in a good practice, so people like to come back and look for the birds times, not only one time, but several times. We work with huge projects like EU projects, have different stations in the high north on the northern hemisphere, and Svanhovd is one of these posts down there. So we are a part of this network of Interact. So the Hornsund and Akerøy and Blueberries and such is also, which other partners also in our EDU-ARCTIC project. So it's coming people from different places of the world making research, and I'm also making virtual field work for these people, so they can ask me to go to the field to make collection of things, whatever. Basically do it. Technology is also a part of the monitoring in the system. We work quite a lot with regulation of phenology together with the Russian Zapovedniks and Russian nature reserves and other research institutions in Russia. I started here in Svanhovd about 20 years ago in 1995, and making quite a lot of research together with my Finnish and Russian part. The project which you are dealing with now, one of the things which is important for me is to understand how you can be better interested in drones and modern systems and make new progress. So I'd like you to make projects and part of the competitions of the EDU-ARCTIC, and also look for the monitoring and try to understand what the monitoring system in the EDU-ARCTIC can provide information that you can get better results in your schoolwork. Very important species, I have to tell you about this. This is the freshwater pearl mussel. I find the name of of the Romanian name. Sea mussels, and they're very, very nice underwater. So this is a picture from a small creek underwater. Different if this is male. This is a female, and this is a male. This is also a male. This is a female. This is not very happy. This is very happy. So we can see of the mussels. It's just me. So this is in the summer part, basically from May until October. And the ice is getting thicker than 1 inch. Then I have to stop swimming underwater because 1 inch of 2.5 centimeters of ice is too hard to through. Then I manage to knock through. But here looking, you see the chains in this metal here river, which is making a section. So I'm looking for small mussel in the section here. That's why I'm there, and this dog is in what I'm doing. 8 hours per day or something during the summer. I quite a lot. I will several hundred days per year in field and in different countries. This also is having a life cycle. So the mamas and the papas is letting the sperm into the water, and the sperm is fertilizing the eggs in the mama mussel, and the larva is going into fish. And here on this you see white dots on the gills of this fish that actually first small balloons of larvae from these mussels, which then developing and living as small parasites on the gills through the winter. So in this process here happens in the autumn, and they live in this on the gills through the winter, and in the summer, early summer, they fall out, make the opening of the cysts of the small balloons, and then the mussels is falling down into the sediment of the river. And for the fish, actually, so killing the fish, and actually giving, when the mussel is open its small balloons or cysts, then providing hormones and proteins, which is influencing and improving, getting better health condition on the fish. The immune system is getting better. So mussels is very important to get strong populations of the salmon and the trout. I have been nearly totally extincted in Poland and basically a lot of European countries. But this mussel from dead shells, and when I'm swimming in the rivers I find the shells from the dead animals, then we make the cutting of them, and then see how old they are. So if you notice here, this is this part, and this part is this outer part. So here you see from the very old mussel then towards the younger. They can be 200 years old, more than years old, even 300 years. Imagine, very long ago. So basically when the Napoleon War, and there was middle-aged individuals. Here you see such a shell, and you can see with fluorescence microscope, you see annual rings here, the increments or the growth from every year. See this, and this part you see very, very fine, a lot of years. So this is more than 40 years in this inner period, and together this is about more than 200 years. So this has been close to 300 years. What you see here. Here you see these increments, these growth zones of muscle, and here I'm using a laser to out and then to collect the pollutants that was in the muscle in this period of the life. So this is the recent year, actually 2012, when the muscle was collected, and they're back in history. So here we can read what happened during the 2012 until back in history to 1980s, for example. And here you can see what happened about 1900. Here we can see what happened with the pollution been changing. So the nickel melter, we can measure this in the zone of mussels in different areas. And here you see before the nickel melter was made, the nickel melter was operating in 1940s of war. After the war, this is the blue, and after in the period when the nickel melter was working, then we see. So we see the copper a little bit less actually, but iron, magnesium, mangan, and actually nickel and these things was not making so much influence to the mussel shell. In the shell of the mussel, not in the tissue, not the flesh of the mussel. Okay. More about this on a later lecture. But one thing is interesting because the mussel is cleaning. One such mussel that you saw is cleaning about 50 liters of water per day. 50 liters per day. Make a lot of influence to the quality of the water. The ecosystem service of the mussel is very important to keep clean water so you can drink the water and also the fish can survive in the water. The thing in the fresh water, this is a spongy. Them on the water like this, but they are other places. Inside in the sponges, there's a lot of very interesting things that I will tell you later about. Another lecture. Also with how we can use the blueberries, for example. So we have work on the pollutants that we find in the different type of the berries in the different places. So nickel is here, my place is here, and then we collect the berries, and then we can see how much is the effect. This place here is these places north of the nickel, because the nickel, like you saw on the previous picture, that the smoke was blowing into the Barents Sea and taking the pollution this direction. So the places is a bit higher up is little effect of the nickel. These places here is having effect of the nickel, which is actually not very well. We should not eat too much blueberry from this area, for example. But the difference in the people from the Norwegian side, from the Finnish side, and the Russian side, and with the Finnish people is eating much more berries compared to the Russians. And Norwegian is eating in between. Also working with these things, this is the mosses, and then we can make comparison how this is changing through the history, 3 years on evolution of the concentration of the nickel. So from the 90 huge pollutions in Europe in the 1960s, 70s, made quite a bad quality, but this quality has become much more better in the south part of Norway. But better in this far north nickel melter. So this is the effect of the nickel melter is still quite strong. You see the green parts here. This is because of the long transported effect from other countries in Norway and also southern part of Norway. The big Norwegian sinner, which is down here, and one inside here someplace. But always the Norwegian companies making nickel has disappeared. I wanted to tell about how to make a project. So this is a type of my recipe. I always need to understand what is a problem, what is the idea, and then I need to make the hypothesis. Correct, or can this be wrong? basic thing in science is to understand how we can say if a thing is correct or it is wrong. But we don't think correct. We have to use the statistics way to say if it is correct or probably it is wrong. Probably. So then we need to understand how to make the investigation, what type of investigation to make the analysis of the hypothesis, and also how to make this statistics in the analysis. Investigation is very, very, very interesting and very, very problematic. Because how many times do you need to make an investigation? How many birds do I need? How many mice do I need to make a good result, which can be statistically and scientifically good? Things with phenology, then we have only one chance to get the correct information when we are looking into the nature. Therefore, in the phenology and the monitoring program of the EDU-ARCTIC, then we like to have as many schools participating as possible. This is the most important thing in science. Who will pay for the investigations? And then you have to find who can be paying, and then you need to make the plans together, or the plans for the investigation is okay for the institution or the bank or the person which is paying for this investment. Only to carry out the test, which can be horrifying and horrible because of mosquitoes, high temperature, too much rain, or whatever. So in our area we have the winter, it's approximately 8 months outside now. Like I said, now the temperature is 6.9 degrees, so it's quite warm. We still have approximately 80 centimeters of snow. Per meter, 60 centimeters of frost in the ground. So this year the spring is a little bit late, but we need to prepare for how to make these phenological registrations and all these things, and then we have to put up the schedules on we are going to do this different type of projects. This is when the weather is making you ideas on how to have nice weather or bad. Making the report, you need to plan in the beginning how you shall make your investigations, how you shall make the tests, how you make the report, and how to make the lectures, and also make newspaper, television, or all things to make this into plan in the beginning of the project. And then you have to struggle and try to publish this in international publications. It's fantastic to be a scientist. It's interesting to be a researcher. So scientist and researcher is basically the same thing, but small things. The scientist is basically working with the basic issues, but the researcher is trying to understand what is happening and going on and use this into other type of community, into the society with the people. A little small details. Educated from the University of Oslo in the 1980s. I had to dive, as you saw, diving in 1979. So it's 2 years that we have been an underwater worker. It's something like 2 to 3 weeks underwater through the year. Then I've been working here with the out of ecology research in the high north. Background from work in tropics, from the European systems, and now I work a little bit more with these European areas as well. Okay, so this is the last picture showing you this area of my station. So I will give with some other lectures later, so I hope that you can find to listen to them if they are fitting for your educational program and your school day. you very much for listening to me. Thank you